My dear students, I hope that we don't have any problem with the I'm trying to follow from the at the same time from the YouTube channel. Let me see. I decrease my voice. Yes. Firstly, I want to tell that we are going to have. There are now 9 watching students, I think. Yeah, the Mr. Rajai also he's following us. So the sound is coming, and we may start to our lessons. Sorry for technical problems. Because of that one, I'm a bit late. I couldn't arrange the things now. And we are going to start the complex numbers. Here it is. Okay, these are the last questions. Now I'm going to start with some reminding. Here it is firstly. About the complex numbers. Yes, now about the complex numbers, I want to remind you about the values. Z is equal to a plus bi, it was, if you remember. And if you want a and b elements of real number, it was elements of real numbers. And here also the modulus or conjugate. Let me firstly remind you about the conjugate. Conjugate was equal to a minus bi. If z is equal to a plus bi, z conjugate it's going to be equal to a minus bi. And the multiplication and division rules are like a plus bi times, if you want to multiply c plus di, was a times c and a times di, like normal multiplication we were doing here. And then bi and c di you're going to multiply. And here the important part, also I square is equal to -1. We shouldn't forget that one. Or I is equal to I square is equal to -1. I cube is equal to minus I, and I to the power of 4 is equal to, it's going to be equal to I to the power of 4, it's going to be equal to 1. So the powers are going to continue like that. I to the power of 5, it's going to be again I to the power of 6 is equal to -1, I to the power of 7 is going to be minus I, and I to the power of 8, it's going to be equal to I. So shortly, briefly, I'm trying to complete the complex numbers till this part, and here there are the, especially we are going to use these properties in our solutions. I'm trying to come to these properties. Then division there was, if there is a term like this a plus bi, we were multiplying by the conjugate a minus bi to get the denominator. Real number, and the result it becomes like this: a minus bi over a square plus b square. A minus bi times a plus bi is equal to a square plus b square, because bi square becomes b square I square, and I square is equal to -1, so minus bi square becomes plus b square. And here this was the division form. And the modulus was the distance. The last one is the modulus. Modulus is the distance between the point of the z and the origin it was. And this is z modulus it's going to be. and this is the A value, and this is the BI value. BI value, the distance of B, here the distance it's going to be equal to B, and here the distance is A. So by using the Pythagorean theorem, A squared plus B squared is equal to A squared plus B squared is equal to Z modules square. It's going to be, this is the Pythagorean theorem. So if we shortly write, square root of A squared plus B squared is equal to Z module is going to be. So this is the distance between the complex number and the origin, and it is called module, and we are showing with absolute value sign. Here, this is another property that if it is Z1 and Z2 are complex number, Z1 module square is equal to Z1 times Z1 conjugate. And if you remember, this is A plus BI. And I told you that module is equal to A minus BI. So this is equal to A minus BI. And it's equal to A square plus B square. If you remember, I said like that to you. A square plus B square, because minus BI square, it's going to be equal to B square. Then here we are going to get A square plus B square. And at the end, Z1 module square is equal to A square plus B square. We are going to get, this is the Pythagorean theorem. Here the property of addition and subtraction. This is same for the subtraction also. Z1 plus Z2 module, pardon, conjugate, sorry. Conjugate is equal to Z1 conjugate plus Z2 conjugate. So you may distribute to conjugate sign, or multiplication is not going to affect the operation. Conjugate operation, Z1 times Z2 conjugate is going to be Z1 conjugate times Z2 conjugate. And the last one, this is Z1 conjugate, Z1 conjugate and conjugate. Double conjugate, it gives again back the number Z1. And the module also, it's not going to affect our operation, multiplication operation. It is not true for, we cannot say this one also, Z1 plus Z2 module is not equal to Z1 module times plus Z2 module. Also, I need to remind you about that one. Here the places are important, that's why I'm going to clean this part. And I think till this part, I hope that everything is okay. So we are going to start here to solve the questions about the complex numbers. Yes, the first question I got from the blue book, and the translation, there may be a problem about the translations, maybe. Here, okay. I think there was a problem about the connections, so again, I'm repeating the same thing. Do you hear my voice? I'm going to wait a bit because yeah. So I may continue. Mr. Antidote, I think one of, yeah. So he said we may, you are getting the voice, so we may continue. Sorry for internet connection. It is because of the internet connection. I'm trying to stream from the school, but I think there is a problem. You know, the weather in Tetovo. Now I'm streaming from Tetovo, and the weather is not good. Probably it's affecting the internet connection also. So let me continue from the first question in Blue Book. And this is our translation, so there may be problem about the translations. With respect to this translation, I'm going to solve the question. If there is a mistake, you may remind me about you may check the questions and you may remind me about the problems. Firstly, 1 plus I to root 3 to the over 2 to the power of 60 plus 1 plus I root 3 over 2 to the power of 30. This is the question here. And of course, it's obvious that 60th power of the number we cannot find easily. And if we cannot find easily, we should find some tricks for this solution. And the tricks are to get the second or third power of the complex number and try to find easy numbers. So if I want to get some easy numbers, I'm going to first get the square of this number, because these two numbers, they are same. Here, square of this number or cube of this number, and maybe I will find easy number. Then I'm going to get the power of power rule, which means a to the power of n. Yes, another technical problem. So I'm going to close this one and I'm going to reopen because it's causing losing the internet connection, causing this kind of problem. So I'm going to one more time open the file again. Sorry. Here it is. Okay. Now, here are the things that I repeat. Yeah. Now, here a square, I said a to the power of n to the power of m I'm going to get. And here, before starting, I'll say if this is equal to x, then this is going to be 1 plus I root 3 over 2, and it's going to be equal to x square I'm going to find, which is equal to 1 plus I root 3 over 2 to the power of 2 it's going to be. Then x square will be equal to 1 plus I root 3 square over 2 square it's going to be. Then x square will be equal to 1 square plus 2 root 3i plus root 3i square. This is the expansion of square. You know, a plus b parenthesis square is equal to a square plus 2ab plus b square it's going to be. So all over 4 here it is. And x square it's going to be equal to 1 square 1 plus 2 root 3i, and this is the last one, and it's going to be 3i square. 3i square, you know, here let me show 3i square. I square is equal to -1. That's why it's going to be equal to -3. So this is -3 all over 4. It's going to be okay. Here a bit to get smaller this expression to find a place to write better. Then x squared, it's going to be equal to x squared. It's going to be equal to minus 2 plus 2 root 3 over 4. If I get 2 parentheses, 2 times minus 1 plus root 3 I, sorry, I forget I here, all over 2 times 2, which is equal to minus 1 plus root 3 over 2, it's going to be. Okay, then what we are going to do here, we couldn't get any simple number to get the power of it. Then I'm going to try x to the power of 3. What is x to the power of 3? X to the power of 3 is equal to x times x to the power of 2. You know that one. So it's going to be equal to 1 plus root 3i over 2 times 1 minus 1 plus root 3i over 2. It's going to be, this is minus, I can rewrite this one like this, root 3i plus 1 times root 3i minus 1 all over 4. It can be. Why I wrote like this? Because minus 1 plus root 3i is equal to root 3i minus 1. You know that one? And when we have a plus b times a minus b, this is equal to a squared minus b squared. So this is root 3i squared, minus 1 squared all over 4 it's going to be. And you know that one, it's equal to root 3i squared is equal to minus 3 minus 1 all over 4. So it's equal to minus 4 over 4, which is equal to minus 1 is going to be. So if it is minus 1, here I got x cubed is equal to minus 1, and this is the expected result that I'm looking for, because x to the power of, this is x to the power of 60 now, and this is x to the power of 30, and both of them can be written in terms of 3, like a to the power of n to the power of m is equal to, I didn't write the result what it is, a to the power of n times m. You know that one. Okay, then I'm going to move a bit downward, and here it is. Here, maybe I will write here. This is the last part now, x to the power of, sorry, here. I'm going to write here, a bit confusing maybe, but x to the power of 60 plus x to the power of 30. Now, this is x, and x to the power of 60, x to the power of 30. Okay, then x to the power of 60 is going to be equal to x to the power of minus 1 to the power of, minus 1 is the, or let me write like this, x to the power of 3 to the power of 20 plus x to the power of 3 to the power of 10. 3 times 20 makes 60, 3 times 10 makes 30. So the result here, it's going to be a bit downward. I'm going to come. Maybe we are going to lose the question, but later I will correct that part also. X to the power of 60 plus x to the power of 30, it's going to be equal to minus 1 to the power of 20 plus minus 1 to the power of 10. That's equal to 1 plus 1, and at the end the result is equal to 2. It's going to be. So the answer of this question here, let me get a bit smaller this expression here, where it is. Smaller. Okay, now you may see better, I think. Yeah, and it's going to be at the end it's going to be equal to 2, the result of this operation. Yes, now I solved the question, and I'm going to wait for the yeah, that was simple. And we have some difficult questions, Amara Demi. And we have some, I'm going to have some time to write these expressions. I'm going to give you here 2 or 3 minutes to write all the thing to your notebook. because this is going to be like regular lesson, and you're going to have time to ask question here, and I'm going to check on the other page what are the questions, and I'm going to try to explain. Then I'm going to continue with the second question. So now I'm waiting for the you're going to write the solutions, and if you have questions, I'm waiting for that questions also. As I see here, I don't know, but I'm following at the same time from other other page, and how is my writings. As I see, you can read the writings. I hope you can read the writings. And the last part is here we have difference between the time. I think you are getting 10 seconds later or 20 seconds later. That's why sorry for that one. Yeah, about the modulus, there is one question. When we do the modulus and we get the perfect root, is the modulus gonna have positive and negative values or just positive one? The answer is only positive one, because we are talking about distance, and distance always positive. So modulus, that's why maybe it's written in absolute value also. Here it is, let's say, modulus of the z, it's representing at the same time distance, and it's going to be always greater than 0. So also a square plus b square, they're real numbers. A square always positive, b square always positive. Non-negative, actually, the true term is non-negative. So they are going to be always greater or equal to 0. And the z module always greater or equal to 0. Minimum value, it will be equal to 0. For that one, z square also, it's going to be here. A square plus b square is equal to z module square. Okay. I hope that this will be the answer. But as I told you, now I finished in my drawing and I'm watching that one now, which means 20 seconds, I think, late, or 30 seconds. I'm not sure about that one. By the way, can I get the names of the students? Can they write from the chat part? And it will be proof for us who follow the lessons. Please, can you write your names and surnames and the school at the chat part? And we will make attendance here. Digital attendance, it's going to be. When we close this one, it's going to be proof for us later for the attendance, as I said. By the way, I couldn't inform myself because I was a bit late. So my name is Erdener Süngü. I'm from Tetova College, Yahya Kemal College. Yes, Ristina Mitraska. And I'm writing here. Yes. many Karpuz students in Strumica, and the first one was from Struga. Yes, Ristina from Struga, Amar from Teto. Okay. Okay, I'm going to continue. While you're writing, I'm going to continue with the second question. Here we have one question about the again the power rule, and one complex number 1 plus I over root 2. Normally this is the complex number. It is not in standard form. 1 plus I over root 2 will be written like 1 over root 2 plus I over root 2 also, and or 1 over root 2 plus 1 over root 2 I, and this is the standard form of the complex number. It will be okay. Then here 1 plus I root 2 n to the power of n plus 4, 1 minus I root 2 to the power of n plus 4, and here these are 1 plus I root 2 to the power of n plus 1 minus I root 2 to the power of n. How to solve these questions? Of course, we don't know n value. That's why we are going to try to get the in terms of n, because there is addition here. If it is multiplication, we will try to multiply them. But if it is addition, you should get common term parentheses for this kind of questions. So it's going to be like this: 1 plus I over root 2 to the power of n times 1 plus I over root 2 to the power of 4. You know that a to the power of n plus m is equal to a to the power of n times, the wrong place for the times here, times a to the power of m. It's going to be. So if I write the things here again, this is the first term. Then the second term is here. Let me change the color of writing, not to mix with this one. Okay, plus 1 minus I over root 2 to the power of n times 1 plus 1 minus, I over root 2 to the power of 4 plus 1 plus I over root 2 to the power of n plus 1 minus I over root 2 to the power of n. It's going to be. So we have now these terms here with addition. If we separate a big notations maybe, here these are common. We will have common terms here like 1 plus I over root 2 to the power of n parentheses. These two I'm getting now here, this one and this one. Then 1 plus I over root 2 to the power of 4 plus 1 it's going to be, because when you get 1 plus I over root 2 here, you're going to leave 1 plus I root 2 to the power of 4 plus, this is, you got everything, and instead of here we have the invisible coefficient 1. That's this number here. Okay, then plus 1 minus I over root 2 to the power of n times the same thing for the 1 minus I over root 2 to the power of n. Here this one and this one and this one is, this one has common term, actually this one totally, this is the term, because, and when you get common term 1 minus I over root 2, then this part it's going to be 1 minus I over root 2 to the power of 4 plus plus 1 it's going to be. So I need to calculate here because I cannot do any operation because I don't know n here. And there must be some tricky part here. I need to find 1 plus I over root 2 to the power of 4, what it is. Then I'm going to try to get the answer. And I'm going to find here one by one. I'm going to separate here, and 1 plus I over root 2 to the power of 2, because I cannot get directly. It will be difficult. It will be difficult for me to get to the fourth power. That's why I'm going to get the squares of it firstly. Then it's going to be equal to 1 plus 1 plus 2i plus I squared. This is the expansion of 1 plus I squared, and the denominator root 2 this is going to be root 2 square, which is equal to 2. So I square is equal to minus 1. So minus 1 and plus 1, they simplify each other. So we have 2i over 2, which is equal to I. And this is 1 plus I root 2 square. So it's equal to I. And if I get the square of it, if I get the one more time square of it, I square, which is the square of this expression, at the same time square of this one, it's going to be, and it's equal to minus 1. And why I get the square of square is equal to 1 plus I root 2 to the power of 4, it's going to be. Then this is minus 1, and minus 1 plus 1, it's going to be here, and that's equal to 0. So if it is equal to 0, I may simplify the term here. Sorry, I'm going to make it a bit smaller here, and I'm going to get distance here. Yes, and if this is equal to 0, then this is 1 plus I over root 2 to the power of n times, and this is 1 plus I over root 2 to the power of n times 0. So this becomes 0. And here for 1 minus I over root 2 to the power of n, 1 minus I over root 2 to the power of 2 is going to be equal to, I'm going to do the same operation here, 1 minus 2i plus I square, only minus 2i it's going to be, but that's not going to affect the result because we are looking for the and this is going to be minus 2i over 2, which is equal to minus I. So if you get the square of it, 1 minus I over root 2 to the power of 4, sorry, writing down like this, it's equal to minus I square, it's going to be, which is equal to I square. That's also same, it's equal to minus 1. And here 1 plus, pardon, I minus 1 minus 1 minus I over root 2 to the power of n times minus 1 plus 1. That makes 0. And if it is 0, this is completely 0, and this is completely 0. 0 plus, the answer is going to be 0 plus 0, which is equal to 0. Okay, now I finished the solution, and I'm expecting that you are going to write this one for 2 or 3 minutes. You have time for this one. If there is a question, I'll get the question. Please use your time efficiently. And do not hesitate to ask questions. How are the holidays going for you? Holiday is working day for me. I was trying to complete my lessons, online lessons that I was sending you via YouTube, you remember? And it was going like that. Okay, let's continue with the new question. Here it is. Here this question a bit, we need to pay attention a bit about the question. It's like the previous one. And here we are going to try to get, we are going to get the answers step by step. That's why you need to follow the steps carefully. And let me start. Firstly, of course, it's not easy to find one by one all of the terms here. So we are going to try to get common terms here. And I'm going to start with this one. I'm going to say z is equal to 1 minus I over root 2. So this is the first thing that you need to know. Then 1 minus I, the sum is going to be equal to z firstly. Then I'm going to get 1 minus I root 2 square. In the previous question I got, and it was equal to, if you remember, it was equal to minus I. Here it is, where it was 1 minus, yes, minus I it was. So I'm going to get minus I for the z square is equal to minus I. And z cube, it's going to be equal to, z times minus I, which is equal to minus, minus zi, and z to the power of 4, it's going to be equal to z squared, which is equal to minus I squared minus I squared, which is equal to 1, or here, yes, I squared, I can say for that one. Then the z to the power of 5 is equal to z times I squared, because z to the power of 5 is equal to z to the power of 4 times, you know that one, z to the power of 1. And the last one is z to the power of 6. Z to the power of 6, the last one I'm saying because I'm not going to continue anymore. I think you got the logic of it. Z6 is equal to z times, or here it's going to be equal to z to the power of 6, and z to the power of 6, it's going to be equal to z to the power of 5 is equal to, if it is equal to, z to the power of 5 is equal to z times I squared. So z to the power of 6 is going to be equal to z squared to the power of z squared to the power of 3, which is equal to minus I to the power of 3, which is equal to minus I cube, it's going to be. So I'm going to write the terms here again. Z plus, then plus minus I plus z cube, this was z square, z cube, z to the power of 4, but I'm going to continue till z to the power of 6, then minus I, then z cube is equal to minus z times minus I, and plus z to the power of 4, it's equal to I square, then again z to the power of 6, zi square, and z to the power of 6, again in terms of I have written, which is equal to minus I cube, and it's obvious, plus, and it's going to continue, but I'm not going to write the last one. I want you to see firstly on this sequence, z minus I plus, minus zi plus I square plus zi square minus I cube, and it's not difficult to guess what is the term here. If it is minus I cube z, or z minus z I cube it's going to be, and as you see, minus I square, minus I cube again, and minus z square minus I cube. It's going to continue like this, and now I'm writing the last terms here. The last terms, of course, if it is I to the power of 6, it's equal to minus I to the power of 3, then I to the power of 1996. I'm going to get the half of them here. This is z to the power of 2, z to the power of, this is z to the power of 4, this is z to the power of 6. So half of them, it is equal to 998. I think it's going to be, yes, 998 it's going to be. These are the last terms, and here the last terms are going to be equal to I to the power of 998. Sorry, this is 998, and plus I to the power of z times I to the power of 998 it's going to be. Okay. I square is equal to minus 1. I square is equal to minus 1, but I'm going to try to get I square is equal to not 1. I wrote there 1 square, like 1 square maybe. Yes, I square it is. Minus I square is equal to, it's equal to I square. I tried right there. I didn't see, sorry, Vlatko, your message. Now I was focusing to my solution. That's why when I checked the stream, I saw that one, your question here. And here, again, I'm repeating this part. I to the power of 900, I to the power of, or 1 plus 1 minus I over root 2 to the power of 1997 is equal to z times 1 minus I over root 2 to the power of 900, or 1996, you know that one. Z times, this is I to the power of, because z squared is equal to minus I to the power of 998 it's going to be. The last term, it must be like this. And I got one sequence here. If you understood that sequence, here it is. And the terms with the, some of the terms with the z, some of them without z. And if I get z parentheses here, it's going to be like this. Z minus zi plus zi square. And here, what it's going to be, then minus zi cube, yes, 1 plus 1 minus it's continuing, and till it's going to continue zi to the power of 900, zi to the power of 998. Then here plus, we are going to continue with the other terms, minus I plus I square, and here it's going to be equal to, and then it's going to be equal to minus I cube, yes, minus I cube. Then it's going to continue like this, and the last term it's going to be I to the power of 998. 1 minus 1 plus, it's continuing, and in the order, the odd powers with negative, even powers with positive value. That's why 998 must be positive. I didn't say that part, but here what we are going to do, if we get the z parentheses here, I cannot get this one also, because if I get this one, I need to leave this one out, then minus z times, or plus z times minus I, and minus I plus I square minus I cube plus I to the power of 4, and it's going to continue till I to the power of 998. Then here the term is also minus I, in parentheses I'm going to write minus I plus I square minus I cube, and that's going to continue till I to the power of 998. Okay, then this, as you see, this term and this term is common. What we are going to do here, we are going to get z parent now minus I plus I square parentheses z plus z times here, pardon, when you get this term parenthesis z plus 1, it's going to be z plus 1 times minus I plus I square minus I cube plus I to the power of 4 plus, it's going to continue. It is not minus, I got plus parenthesis. I got plus parenthesis. When I see the question, no, it's not minus. I got plus and I didn't change the signs. You see, this is, I put the parenthesis here and like here, the plus sign there was here and I didn't change the sign. I put the plus sign here. Okay, then it's going to be equal to minus I plus I square minus I cube plus I4 and I to the power of 998 it's going to be. And here there is 1 here in front, that's why this is the term 1 here, invisible coefficient. And here what we are going to do at this part, what we are going to do here, we know that from the order minus I, we have here I square is equal to, as you said, minus 1 minus I cube, it's going to be equal to plus I, and I to the power of 4, it's going to be equal to 1. So this is minus I cube is equal to, pardon, this is, I didn't write correctly. Now we have minus I, then plus I square, this is equal to minus 1, and minus I cube, this is equal to plus, normally I cube is equal to minus I, and minus I, it's going to be plus I, and I to the power of 4, it's not going to change, it is equal to 1, because it has plus sign. And when you add this 4 as a 4 group here, minus I plus I, it's going to simplify each other, minus 1 plus 1, it's going to simplify each other. So this sum here, this sum, it's going to be equal to 0. So in every 4 unit, we are going to get 0. In every 4 unit, we are going to get 0, means till, I think, 996, because 996 is the last numbers that are divisible by 4, till 996, it's equal to 0. So this is going to be like this, z plus 1 times 0 plus 0 plus, it's going to continue like this, I to the power of 997, because 996 is equal to 0, plus I to the power of 998. And these are equal to here. I'm going to continue a bit down. This is going to be equal to z plus 1 times I to the power of 997. You remember this is going to be minus I in order, it's going like that, minus I, and this is going to be the I square. So all they are 0, the sum is 0, minus I, and the last one is going to be equal to plus I square. This is going to be equal to I square is equal to minus 1, so it's equal to minus I minus 1, which is equal to, it's minus 900, yes, sorry, I'm sorry. Thank you very much. Minus I to the power of 997. As I told you, you're writing something here. After 30 seconds, I'm correcting that one, because there's a time difference between the stream and what I'm writing here. So minus I to the power of 997, so it's going to be equal to minus I plus I squared. This part was, I think it's true again, and here it's going to be equal to z plus 1 times I squared is equal to minus 1, so minus 1 minus I it must be. And if I multiply, these are here z plus minus z, then here this is going to be z minus zi, and minus 1 minus I, it's going to be, why I multiply like this, because I want to simplify this too. And minus zi I got here, and all of them there. Minus zi, we know that it's equal to 1 minus root 2, 1 minus I over root 2 times, minus sign here, times I, and minus 1 minus I, it's going to be. So the result here, it's going to be like this. If I multiply this one by I, it's going to be, this one I'm going to multiply by I, it's going to be equal to minus I minus plus I square all over root 2 and minus, pardon, not equal to sign, minus 1 minus I, it's going to be. Okay, then it's equal to here, this I squared, it's going to be equal to minus 1 again, minus I minus 1 all over root 2. And as I see here, this part is also same. So if I multiply by here, I will get the common term parentheses like this, minus plus minus 1 minus I. Again, I wrote with plus sign. This, when you distribute the plus sign, it's going to be positive inside. Sorry, I need to make it a bit smaller maybe. I don't have place to write. Okay, nice. Okay, then here minus 1 minus I minus 1, they are same terms, so I will get the parentheses like this, minus 1, it will be equal to minus 1 minus I times, this is going to be 1 over root 2 plus 1, and this is the answer of the question. Here you can distribute this term to the this part, and I mean, I'm talking about this term. You may distribute and you may find standard form of the complex number, but this is also enough for us. Okay. Now it's minus. Yes, this is, I'm reading them. I was reading the terms, and I'm going to give the page like this now. I'm going to wait you to write the things, and then I'm going to give 4 or 5 minutes for this one. Are there any questions? Okay, I'm going to continue with the, there's no question as I see, and I recognize that there are 2 dislikes for the. I hope that you'll like the later questions. Let me continue with the other question here. This is the 4th question, I think. Here, alpha is equal to 1 over 2 times. Let me make it bigger. Alpha is equal to 1 over 2 times minus I plus I root 3. Sorry, but it's not easy to talk for 1 hour like this. And prove that I squared plus alpha squared plus alpha plus 1 is equal to 0 and alpha cube is equal to 1. And determine the real number, imaginary parts, real and imaginary parts of the number. Here, a alpha square plus b over a plus b alpha, where a plus b alpha is not equal to 0. If it is equal to 0, you know that one, it cannot be equal to. If it's equal to 0, it cannot be it cannot be real number, or it won't be defined function. So we are going to firstly try to find what is the first. We are going to try to find what is alpha squared plus alpha plus 1. And for that one here, alpha squared plus alpha plus 1, I said, there are 2 ways you can calculate the, you can do like this, alpha is equal to minus 1 over 2 plus minus I root 3 over 2. So you can get alpha square, what it is, alpha square what it is, then alpha what it is, and you will add that one to 1. Or if you are familiar to complex numbers, quadratic equations, you know that this is quadratic equation, and x squared plus x plus 1, if it's equal to 0, then by using the delta method, delta is equal to b squared minus 4ac. You know that one. Delta is equal to 1 square minus 4 times 1 times 1. Delta is equal to minus 3. Root of delta, it's equal to root of minus 3, which is equal to root 3i, going to be. Then here it's going to be equal to the x1 is equal to minus b plus root of delta over 2a, which is equal to x1 is equal to, x1 is equal to minus b. What is minus b? Minus b is equal to minus 1 plus root of 3i over 2 times 1, that's 2, and x2 it's going to be equal to minus 1 minus root of 3i all over 2, or x1 and x2 when you write minus 1 plus minus root of 3i over 2. So if you know this quadratic equation, you can easily find this is the root. So the root solutions, I mean, when you replace the root here, I mean x1 and x2, when you replace in the quadratic equation, you are getting the value 0. So x1 and x2 must satisfy this quadratic equation, and it's proof for us. Alpha squared plus alpha plus 1, it's going to be equal to 0. Here, this number and this number, as you see, it's same. Then alpha cube is equal to 1. It's not difficult to find also this one, because here alpha cube minus 1 must be equal to 0, and alpha minus 1 times alpha squared plus alpha plus 1, it's equal to 0. It's going to be here. This is the I factorize a cube minus b cube. A cube minus b cube, you know that one is here. A cube minus b cube is equal to a minus b times a square plus ab plus b square. So if this is equal to 0, then alpha minus 1 times 0, it's going to be equal to 0. So alpha this expression, hold this expression, if it's equal to 0, alpha cube minus 1 if it's equal to 0, alpha cube it's going to be equal to 1. Also, this is the proof of the second part. And now I'm going to try to get this expression. How to get this one? Like this I'm going to do here. If I find that alpha cube is equal to, or let me get smaller these parts. Okay, now I'm going to try to determine this number. A times alpha square plus b over a plus b times alpha. I'm going to multiply numerator and denominator by alpha. This is the trick of the question. Then you're going to get a times alpha cube plus b alpha all over a plus b alpha times alpha. I didn't multiply because I got at upper part a plus b alpha, and here it's going to be equal to 1. So this expression is equal to a plus b alpha all over a plus b alpha times alpha. And this term is not equal to 0. A plus b alpha is not equal to 0, so you may simplify that one, and the answer is equal to 1 over alpha it's going to be. So this expression, hold this expression, is equal to 1 over alpha, which where alpha is 1 over when you multiply by inside minus 1 plus minus root 3i all over 2 it's going to be. So when you turn this question, I mean, this is integer and denominator is rational number, so you should turn and multiply. It should be like 2 over minus 1 plus minus root 3i, and you're going to multiply by the conjugates, and when you multiply by the conjugates, here it's going to be, you're going to multiply by the minus 1 plus minus and plus. I'm going to change the places of the sign. Plus and minus root 3i, and by the conjugate, if you multiply, you will rationalize the denominator and you will write it in standard form, which is equal to 2 times minus 1 plus root 3i plus and minus root 3i all over. When you multiply by the conjugates, it's going to give you the same result, because z modulo z minus 1 square, it's going to be equal to 1 square and root 3i square is equal to 3 square. So the answer it's going to be equal to, here I'm going to write, this is the, here I'm going to write the last part. It's going to be equal to 2 times minus 1 plus 3i plus minus 3i over 4, which if you simplify, minus 1 plus and minus 3i over 2, it's going to, these are the, this is the value of a alpha square plus b over a plus b alpha, it's going to be, and only I made here multiplication by alpha over 2, which is equal to 1. Okay, is there any question about this solution? If there is no question, I'm going to give you time for solving in your notebook. Yes. The first question with the yellow part, you mean, I think, this part here. Here, this is the question. It says that determine the real and imaginary parts of this question. Here, a alpha squared plus b over a plus b alpha. And I wrote the term here, and I found the alpha. Firstly, alpha cube is equal to 1, and alpha squared plus alpha plus 1 is equal to 0. I prove them here. Then I start to question, determine this part. Then a alpha squared plus b over a plus b alpha. I wrote this term, and this is the tricky part here. We should multiply by alpha over alpha. Why we are multiplying alpha over alpha? Because we want to get the alpha squared as alpha cube. That's why. And when you multiply by one, a alpha cube it's going to be, and plus b alpha it must be. Of course, a and alpha, the terms seems similar. So slow down, and alpha and a look same. Yes, slow down. Slow down. I'm going to try to be a slow down. Sorry. It's root 3 squared it's going to be. Because root 3i it was, and you know, root 3i squared it must be. Thank you very much for correcting the mistake. This is root 3i because if you remember, a plus bi times, I'm going to reopen this one. A minus bi, it's equal to a square plus b square. So this is root 3i squared it should be, which is equal to 3. But I wrote directly 3. Okay, I'm going to start to the next one. Yes. From the Blue Book, this is 493. And these questions, actually, they like to ask this kind of questions by using conjugate, and they're asking here conjugate, and there is a real number, a is equal to u minus uz, u conjugate z all over 1 minus z is real number. This kind of questions they like to ask. Generally, the last years they are asking these kind of questions in Olympiads. If they ask from the complex number regional, I don't know, maybe in regional competition or in municipality competition, there will be questions. I don't think that they will ask in state competition. So we are solving these questions for regional and municipality, I think, and there will be this kind of question. If they ask questions, they are generally asking this kind of questions. Here, this is the first, there is a writing mistake here. This is a is equal to u minus u prime z all over u conjugate z 1 minus z it's going to be. This is the first part. We should be careful about that one. So the question is, it says that the number a is real number, which means this expression is real number. And it is given that u is complex number and z is complex number, but the operation result here, this is going to be real number. How it is possible? Firstly, in which condition complex operation will be real number? Let me explain that one. Here, and I'm going to use this form also. If a is real number, then conjugate of the a also it's going to be real number. This is very important for us. If a is real number, then the conjugate of it, it's going to be real number. Because if it is only, let's say, here, let me write, z is equal to 3. What is the z conjugate? Again, it's 3. Because there is no imaginary part. If it is 3 plus 4i, you will say that z conjugate is 3 minus 4i. But if it is only real number, the conjugate of it, again, it should be itself. So we are going to start with that one. U minus u conjugate z over 1 minus z. It should be equal to, this is a must be equal to a conjugate, which is equal to 1 minus, I'm sorry, u minus u conjugate z over 1 minus u conjugate. Okay, then this conjugate, it's going to be, we can distribute like distribution we can do, and it's going to be like this. U minus u conjugate z over 1 minus z is equal to u conjugate minus u conjugate, double conjugate, and if you remember z conjugate, it's equal to z we said. So instead of this one directly, I'm going to write u times z conjugate over 1 is real number, that's why it's not going to change, 1 minus z conjugate. I made a mistake at the second part here. I think you couldn't see that part. That's why there's no warning in the stream part. Yeah, now it's okay. Okay, what we are going to do, we are going to cross and multiply these terms here, and it's going to be u minus u conjugate z times 1 minus z conjugate, cross the multiplication, is equal to 1 minus z times u conjugate minus u times z conjugate, it's going to be, and I'm going to distribute to both sides. Here, I'm going to apply distribution rule. Sorry, my throat, it started to ache. And u times 1 is equal to u times minus z is equal to minus u z conjugate. U conjugate times Z minus 1, this is also minus and minus, it's going to be equal to minus U conjugate Z, and this is U times Z times minus U conjugate times Z times Z conjugate. Actually, this is going to be plus because both of the sign minus U conjugate Z times minus Z conjugate, it's going to be plus U conjugate Z, Z conjugate is equal to U conjugate minus U Z conjugate minus Z U conjugate plus minus times minus, it's going to be plus U Z Z conjugate. Here, as you see, we have both sides common terms. So UZ conjugate and UZ conjugate minus, they're both of them. I'm simplifying here. Then U conjugate Z and U conjugate Z, this is same. I'm simplifying. They're equal to, they're going to give us 0 when you send the terms to one side. And it's going to be like this. Here, U minus U conjugate, U minus U conjugate, and here plus U conjugate times Z conjugate minus U times Z conjugate. Here I need to is equal to 0. Here I need to remind you about one more information. Z times Z conjugate, if we accept that Z is equal to, where I will write, I'm going to write here. Z times Z conjugate is equal to modulus Z square. How it will be? A plus BI times A minus BI is equal to A square plus B square. Many times I repeat this one. And if you remember the different Pythagorean theorem, I explained that the Pythagorean A square plus B square is equal to Z module square. It's going to be, I said that one. Then here we have, I'm going to follow down. We have this term U minus U conjugate plus U conjugate times Z module square, yes, and Z module square minus U times Z module square, it's going to be equal to 0. And as you see here, if I get Z module parenthesis, U minus U conjugate, if we get Z module parenthesis or minus Z module square parenthesis, it's going to be equal to, again, U minus U conjugate is equal to 0. Again, I'm repeating this part. I got minus Z module square. Z module square parenthesis I got. Normally this one has plus, but if I get minus, this sign must be minus to get this term. This term and this term, now they are same. If I write in parentheses like this, the coefficient here is 1. It's going to be like this. 1 minus Z module square times, these terms are same, U minus U conjugate is equal to 0. So if I need to make it a bit smaller. To have more free space. Okay. Now 1 minus Z module square, it's going to be equal to 1 minus Z module square is equal to 0. 1 minus Z module square is equal to 0, or u minus u conjugate is equal to 0, it's going to be. And when you get this one to the other side, that module square is equal to 1, u is equal to u conjugate. This is not possible, because if u is equal to u conjugate, it means that u is, if it is in that form, u is real number, but u is not real number. At the beginning of the question, it's given that u is complex number. So we know that u is equal to u is not equal to u conjugate, and it means that module square, it must be equal to 1. Find all complex numbers that it says. We found all complex number. This is not the direct answer. You didn't find any x and y value, or you didn't find exactly value, but we know only this one. This is distance. That's why the module of z, it's going to be equal to 1. So for all complex numbers which has the modulus 1, then this expression is true. All complex numbers as a modulus 1 is the answer of the question. All z implies that z module is equal to 1. This is the answer of the question. Yes, all real numbers are complex numbers, but it's given that it's a complex number here. That's why I said like that. And also this won't change the solution here. By the way, now we are going to get 10 minute rest. We are going to, because 10:30 we have break. I skipped the conjugate case. U conjugate is equal to u. Yeah, when they are equal, also this means it is real number, and it is given that it's complex number. That's why I didn't skip that one. I said like this, it's a given complex number. If it is given complex number, I'm understanding from the word given complex number, the given complex number u is one number like a plus bi. That's why it's not possible for, if it is complex number, it's not possible to be only real part. That's why I skip that case. Okay, now for 10 minutes break, I see the you are writing in Macedonian in Macedonian. That's why I didn't understand what you're trying to ask. You're, I think, discussing with your friends. I don't know Macedonian. Is complex with imaginary u is equal to 0. Ne ask not. I'm not understanding Macedonian, so I don't understand. Can you explain how to got 1 times u minus u conjugate plus z module square times is equal to 0? I can explain that part one more time. Here, when we multiply, cross multiply, after this part I think you're asking, when we multiply crossly, we are getting this term. Then I use the distribution law, and I got these terms: u minus u z conjugate and u conjugate z plus u conjugate times z conjugate. At the other side, we have u conjugate minus uz conjugate minus z times u conjugate plus u times z conjugate. Here, the terms, this term and this term is same, and this term and this term is same. On the equation, if you have same terms with plus and minus sign, you may simplify them. I simplified them, then I got the terms to one side. Here, u times u minus u conjugate, and here I explained firstly z times z conjugate is equal to z module square. Then I wrote instead of that one z module square. Then I got z module parentheses. Well, while you are getting z module parentheses, yeah, okay, I got there's a time lapse between between your writings and my readings. That's why I'm explaining 30 seconds. Then I see that one. Sorry for that one, but I hope that will solve that problem with quick internet connection. Now here, this one, it's z module square. And here it is z module square. If I get z module square parentheses, I'll get this one. Z module square parentheses, z module square parentheses gives me u conjugate minus u. U conjugate minus u is the multiplicative inverse of each other. Multiplicative inverse of each other means if you get minus parentheses, this one like z module square times, then it's going to be equal to u minus u conjugate. This term becomes this one. If you distribute, you can get the same term again. So I made that one directly. I got minus z square parentheses, z module square parentheses. Now I'm going to give 10 minutes break. I didn't start to 10 minutes break. After 10 minutes, we will continue again. Okay, now I'm going to continue with the question here. So I wrote the things of complain a bit. Why I'm solving the blue book questions if there is already solutions of it in the blue book questions. But if you check the questions from the in sigmas, you cannot find lots of questions about the complex numbers. Only there are a few questions. So I'm finding that I couldn't find a lot of questions. What I found here, one or two questions I'm solving from similar questions from the blue book and similar questions what I found in blue book and in sigma. I'm trying to solve that kind of questions here. And maybe they won't ask in regional or republic questions, in examinations, regional or republic examinations. That's why I'm going to continue with these questions again. And I think here it's written on the right corner how many pages there are. 8 pages we finished. This is the 8th page. There are 15 slots there, which means we have 7 more solutions. Can you hear my voice now? Okay. Thank you very much, Amar. I was talking by myself, I think. How is the sound now? Okay. Let me continue now. Here, Z1 and Z2 are complex number with property Z1 module, Z2 module is equal to 1. Then Z1 times Z2, Z1 times Z2 is not equal to -1. If it is equal to -1, it will be denominator will be 0. That's why it will be undefined. And here, if Z1 and Z2 are complex numbers, again, I'm understanding that it's a plus bi form. And here we have the Z. I'm going to, sorry, when I start again streaming, it's making problem. I'm going to open it again one more time. Okay. Okay. Now it's writing regularly. Then Z is real number. Here it says that Z is real number, and we are going to prove that one. We are going to use this method. If we show that if Z is real number, Z must be equal to Z conjugate. If it is Z conjugate, then from the previous question, we know that Z is equal to Z conjugate, then Z is real number. Okay, let's start with this form. Z is equal to Z1 plus Z2 over Z1 1 plus Z1 times Z2. One more time, I'm going to ask, sorry, I'm going to stop here and I'm going to ask, can you read can you read the thickness of this one, or this one is better? The first one and the second one. Which one? Can you read the first one? If you can read, it's first one is better for me. Okay, I'm going to continue. Okay, both are okay. There are two comments. The others probably first one is better. Okay, I'm going to continue with the first one. I think first one is better also because you can read better, I think. Okay, Z1 plus Z2. I'm going to multiply here by 1 over Z1 times Z2 here. This is the tricky part in the question. As I told you before, I'm going to try to get Z1 conjugate, and to get that one, I'm multiplying numerator and denominator by the same number, which is 1 over Z1, Z2, 1 over Z1 times Z2, it's going to be. Then the answer it's going to be, if you multiply 1 by 1 here, if you distribute these terms here, Z1 over Z1 times Z2 plus here sorry. Okay, then Z2 over Z1 times Z2, then all over 1 times 1 over here, 1 over Z1 times Z2 plus Z1 times Z2 over Z1 times Z2. Okay, here what we are going to do, we are going to simplify the same numbers. Here this one, Z1 and Z1, then Z2 and Z2. Here we cannot simplify anything, and therefore the third one, we can simplify all of them. Here Z1, Z2, Z2, we can simplify, and we are going to get these answers now. Here it's going to be equal to 1 over Z2 plus 1 over Z1 over 1 over Z1 times Z2 plus 1, it's going to be. Okay, what I'm going to do here, it seems a bit weird. Here, this information I'm going to use. I know that Z1 module square, it's also equal to 1, which means Z1 times Z2 conjugate, Z1 times Z2, Z1 conjugate also. I'm going to rewrite this part with different color because this is out of the solution. Z1 module, pardon, conjugate, Z1 times Z1 conjugate is equal to 1. Here, we are understanding that one. So instead of 1, when I see 1 here, I can write these terms like this. Or let me continue from here. Instead of 1, I'm going to write Z1 times Z1 conjugate, or Z2 times Z2 conjugate. It's same for, because Z1 and Z2, Z1 module and Z2 module, they are equal to 1. So it means that Z2 times Z2 module square is equal to 1. Z2 times Z2 conjugate is also equal to 1. So Here Z2 times Z2 conjugate over Z2 plus Z1 times Z1 conjugate over Z1. Instead of 1, I wrote this term all over. Here we have 1 and down Z1 times Z2. So 1 times 1 is equal to 1. That's why Z1 times Z2 conjugate, which is equal to 1 times, pardon, Z1 conjugate times Z2 times Z2 conjugate. These are all 1 and 1. So multiplication is again 1 all over. Here again, it's equal to Z1 times Z2 plus 1 here. Now I'm going to simplify these terms. Z2, Z2, Z1, 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 Z2, Z2. The expression becomes like this. Z2 conjugate plus Z1 conjugate all over Z1 times Z2 conjugate. Z1 conjugate times Z2 conjugate, you know the property I explained and you remember Z1 times Z2 conjugate is equal to Z1 times Z2 conjugate. It's going to be. So plus 1 here. So this is the last part now. Here I can rewrite this part again, Z1 plus Z2 conjugate all over 1 plus Z1 times Z2 conjugate, which is equal to Z1 plus Z2 all over 1 plus Z1 times Z2 conjugate. If this was Z, this was Z. At the beginning we start with Z. Then I got this is Z also. And what is written inside here? Z. So this is Z conjugate. Z is equal to, it means that Z is equal to, this is Z conjugate. If Z is equal to Z conjugate, it means that the expression here, Z1 plus Z2 over 1 plus Z1 times Z2 is real number. This is the proof of the question. Okay, I'm going to give you time for writing. Sound Okay, now I'm continuing with the new question here. And 1 minus a conjugate b square, prove that minus a minus b square is equal to 1 plus ab square plus ab module square plus a module plus b module square, where a and b complex numbers and a conjugate is the conjugate of complex number a. I think this is the translation. Translation is like this. Here we are going to first see, we need to remember all the properties. If you remember a here z1 or z module square, this is the square, it's equal to z times z conjugate. It's going to be. So if I apply here this one, 1 minus a module b square, it's going to be like this, 1 minus a, directly I'm writing, I'm not going to rewrite this one, I'm going to write this side here again, 1 minus a conjugate times b times 1 minus a conjugate b conjugate. This is z module square, which is equal to z times z conjugate. It's going to be same for the second one also. Here, a minus b times a minus b conjugate. It's going to be is equal to, we are going to continue to this one because we are going to try to get the other side. It's going to be equal to, if I first distribute these conjugates below, it will be like this, 1 minus a conjugate b times 1, the conjugate of real number is at same, conjugate of conjugate minus a b conjugate, a conjugate, it's going to be, it's equal to a and then b conjugate minus a minus b times a conjugate minus b conjugate. It's going to be. And if I here, if I multiply one by one the terms here, it's going to be like 1 times 1 is equal to 1. 1 times minus a conjugate b conjugate, sorry, minus a conjugate b times 1 is equal to minus a conjugate b. Here it's going to be minus and minus plus. That's why a conjugate, a conjugate, then b conjugate. Here b conjugate, it's going to be. Then with minus sign, I'm going to multiply all the terms with minus sign. Minus a conjugate, a conjugate, because there's a minus in front of it. Here a minus b, a times minus b conjugate is equal to minus ab conjugate, and there is one more minus. That's why it's going to be plus a b conjugate minus b a conjugate is equal to minus a conjugate b, and minus minus, it's going to be plus again. Yes. Then minus b conjugate is going to be equal to plus b conjugate, which is equal to one more minus here, b minus b conjugate again, minus minus, this is the third minus, so it's going to be minus b conjugate. Okay, sorry, I forgot the stream. Yeah. Okay, then it's going to be equal to here 1 minus, yeah, I went to other screen to see the stream. That's why it happened again. I'm going to reopen the page. Sorry. Sorry for technical problems. Pardon. Here, 1 minus AB conjugate minus AB conjugate here plus AB conjugate we have. This one and this one and this one. Then here minus A conjugate B plus A conjugate B. They simplify each other. Then this is going to be equal to here 1 plus A conjugate is equal to A times A conjugate. It's equal to module A module square. So A module square A module square times B module square plus or minus, sorry, minus here A times, and this is minus A module square minus B module square. Here the terms are with square, and the second part, I think here there is a mistake in the question. While I was writing the question, I think I wrote wrongly. I think in the square is outside here. Here it should be the square. Now I correct this part, okay? Because you cannot get this one. Here, what I'm going to do is, here I'm going to add minus plus 2A conjugate B conjugate minus 2A, A module B module times A minus 2 A module B module, and the sum here it's equal to 0, but I'm going to use them here. How we can use? We can do like this: 1 plus 2 A module B module plus A module B module square, this term, and I got this one here. Then minus A module square minus 2 A module B module plus, sorry, minus B module square. It's going to be here 1 plus 2A module B module plus AB square. This is the square of the expression. Directly I may write now 1 plus A module times B module square. It's not inside, and I think this sign is also minus. It's going to be, sorry for that one, like I'm changing the question how I think, but the real question, it is not like this, of course. Minus A module square minus B module square. It's going to be. So when I change the question here, Maybe black color is better. Here, firstly with white. Let me clean this part. Then the question, it will be better like this. And then minus here. And I got the solution here. And as I recognize here, while I was writing, I think I made a mistake here. Then I correct the mistake when I was solving the question. Sorry for that mistake. Okay, now you have to write this page. I'm waiting for 3 minutes. Yes, my friend Drin, I think you came later, and as I see at the beginning we were 17 and now we are 16, 15 watching now, which means that we lost some of the students here, or there were some teachers, they were watching this video. Now let me explain two things. Firstly, we are trying to make as much as possible class atmosphere, so writing is one of the important part that you remember the things. That's why we are writing now. At home, you should write the things while you are listening. At the same time, I'm giving time to write. While you are writing, you are learning better. That's why I'm giving this time. And this is like class atmosphere. And second one, and the most important one for me, I cannot explain in 1.5 an hour because all lessons 1.5 an hour, all 1.5 an hour, I cannot continuously talk. That's why that 3 minutes is not writing only. That 3 minutes, it's for me also 3 minutes. I'm resting here. That's difficult to talk 1.5 an hour. I understood that one now while I'm recording this video. I understood that 1.5 an hour is talking or 45 minutes is talking is difficult. So continuously talking is more difficult. That's why I'm giving this 3 minutes. I'm not giving for only writing, and I'm getting rest and drinking water here. That's why it's important for me. And the first one is also that's also important. While you are writing, you are understanding the things. So please write them. I think some of your friends, if I ask now, if I make a tendency now, how many students are watching now? Can you rewrite if I say? I think that we will lose some of them because probably some of them, they are not watching the stream. Yeah. Yes, Amar. As I told you before, I made a mistake while I was writing the question. I completely make mistake. But when we check the original one, we can see that here. This is going to be, yes, it started again. Okay, I'm going to close and open again. Sorry, but the conditions are not enough for me. That's why this kind of technical problems we are having. But I hope that it will be better. Okay, now this question we are going to solve. Here again, A module is equal to 1, B module is equal to 1. Then prove that A minus B module of A minus B over 1 minus A module B, A conjugate B is equal to 1. Also, this is similar with the previous type of questions. Here, I told you before, they like this kind of questions much here, and we are going to solve this kind of questions. Probably they will ask this kind of questions in the olympiad if they ask. The plus inside is okay, and the plus inside was okay. Let's see the yeah. Yes, this must be plus. Okay, I corrected mistake. Thank you very much for one more time. Okay, here we are going to try to understand what is A minus B. Here A 1 minus A conjugate times B. Firstly, I'm going to replace this one with one of them here. The easy for me to choose instead of 1, I can use this one. We know that if A module is equal to 1, sorry, my writing's now inclined a bit. Okay, this is okay now. And it is A is equal to, if A module is equal to 1, which means A times A conjugate A module square is equal to A module is equal to 1, A module square is equal to 1, so A times A conjugate is equal to 1. So we can write like this, A minus B over A times A conjugate minus A conjugate B. We can write here. Here it's going to be equal to A minus B all over A conjugate, and here A conjugate A minus B. A conjugate parentheses I got, so when you get A conjugates, you left A minus B in module again here. Then A minus B and A minus B and A minus B and A minus B we will simplify, and we have to say this one also here. A is not equal to B, because if A is equal to B, if A is equal to B, A minus B will be equal to 0. I don't know, I got the transition, that's why maybe here in the in original part, A is not equal to B, it's given, maybe, I don't know that one. But A minus B, when you simplify, the result will be equal to 1 over A module, which is equal to, here, I have to get this one down. Here it's equal to 1 over A module, because module of 1 is equal to 1, the distance of 1, actually, it's equal to. And we know that A module is equal to 1, which is equal to 1 over 1, then it's equal to 1. So A minus B over 1 minus A module, A conjugate B module is equal to 1 if A module is equal to 1 and B module is equal to 1. This is the proof of it. If there are questions, it's very easy solution for you. Okay, if there is no question, please write this one. In 1 minute, you can write. Okay, now what is, yes. Here I didn't mention, while you are discussing that one, I didn't mention that one, but when you have division inside the module, you can separate like one Z1 over. Evet. Yes. It's making problem again. I'm going to close and I'm going to open it. I wanted to explain this one. Z1 module over Z2 module is equal to Z1 over Z2 is equal to Z1 module over Z2 module. Also, it's going to be. Okay. Let's continue with the new solution. Here, A, B, C are complex numbers such A, B, and C. Module of A, module of B, module of C is equal to 1. Then prove AB plus ABC plus AC is equal to A plus B plus C in module. If the modules are 1, How to prove this one? Firstly, I need to mention this one again. Here, if a is equal to 1, then modulo of a squared is equal to 1. This means that a times a conjugate is equal to 1. B module square is equal to 1, so b times b module is equal to conjugate is equal to 1, sorry. And c module square is equal to 1, which means c times c conjugate is equal to 1. It's going to be. So if you write here a plus ab plus bc plus ac in module, now I'm going to get them in ABC parentheses. So it's going to be like this. I'm going to divide them by 1 over. I'm going to multiply them by 1 over a times b times c. I'm going to multiply them like this. I'm going to do a times b times c all over a times b times c times here AB plus BC plus AC. It's going to be. Here, I'm not going to multiply by the numerator. I'm going to multiply by only the denominator. When I multiply, it's going to be like this: a times b times c. This is equal to 1, by the way, times AB over ABC plus AC over BC over ABC plus AC over ABC. It's going to be here. It's going to be equal to this one is here BC. Then we can separate the modules here. Also, we can use that one. But before that one, I want to simplify the terms here. B and B, C and C, A and A, C and C. So the terms are like this. It's going to be times 1 over C plus 1 over A plus 1 over B. It's going to be, which is equal to here, which is equal to module inside the module. This is here A times B times C. I can rewrite like this. I made a mistake here. I didn't want to write this one here and here. Now I'm separating A times B times C module times module of, in parentheses, 1 over A plus 1 over B plus 1 over C in module. I separate the modules here. In multiplication, it is possible, which means that 1 times Z2 module is equal to Z1 module times Z2 module. I made that one. Okay, then this is going to be equal to here. I'm going to continue downward. Here, at the beginning, in upper part, I wrote this one. A times A module is equal to 1, which means A times A module is equal to 1. So A conjugate, I said A module, sorry, I'm for that one, but I'm confusing these two terms, module and conjugate. 1 over A. A conjugate is equal to 1 over A, and it's going to be A conjugate, it's going to be equal to 1 over A. This is same for all the terms here. All the terms means B and C also. So A module times B module times C module times A conjugate plus B conjugate plus C conjugate, it's going to be. And this is equal to 1 times 1 times 1 times A plus B plus C conjugate. It's going to be here. It's going to be, if you remember, If you remember, I said, but I didn't, I think, said this one in this video. We know that modulo of z and z conjugate, they are going to be equal to each other. So if A, B, C are complex number, sum of them 1 times A plus B plus C module it's going to be. Because this expression is equal to this one, since z is equal to z conjugate. So it's going to be equal to 1 times A plus B plus C module. Now I prove that if I return back up, I mean AB plus BC plus AC is equal to A plus B plus C in module, of course. So at the end, I can write this one, AB module BC plus AC is equal to module of A plus B plus C. It's going to be okay. Now I wrote the what happened to denominator of A times B times C. What happened to denominator A times B times C? When you multiply the upper part here, let me show all the page. Yes, the best fit. Here, when I multiply this expression by this one, I said I am going to multiply only by the denominator. And denominator always goes to denominator here. Then A times B over ABC. A and B I simplify. A and A, B and B I simplify. So the answer becomes 1 over C. Then for this one, the answer is 1 over A. For this one, the answer is 1 over B. And then I wrote this one. 1 A times A conjugate is equal to 1. It means that if you send to the term here, A, it should be division 1 over A. A conjugate is equal to 1 over A. So instead of 1 over A, I wrote A conjugate. Instead of 1 over B, I wrote B conjugate. And instead of C, I wrote 1 over C, I wrote C conjugate. Then I explain the other parts if there's no problem. No problem, Omar. And now you have 3 minutes to write this one. And I'm going to get rest about that one also. Okay, I'm going to continue with the yes, now I'm going to solve 510. Here, a squared plus b squared, find the complex numbers which satisfy the equality a squared plus b squared plus c squared is equal to ab, ac, and AB, BC, and CA. Prove that ABC, they are equal to each other, and ABC vertices of a triangle. This is the English translation, as I understand. It means that ABC, they are equal to each other, or prove that ABC equal to each other, or ABC are vertices of an equilateral triangle. Then a squared plus b squared plus c squared is equal to AB and AB plus BC plus CA, it's going to be. Okay, then here we are going to have the, we are going to have firstly here, firstly I'm going to try to prove this one, a squared plus b, let me make it. Here first like this, a squared plus, actually, a squared plus b squared, we know that it's equal to, here, if I do like a squared plus b squared is equal to ab plus bc plus ca minus c squared. I can do this one for all of the terms. I choose c now. Here I can send another term here, and while I choose this one, a squared plus b squared on this side, I'm going to do also like this. Here I'm going to write plus ab and minus ab one more time, and I add this one. This is equal to 0. Then equation becomes like this: a squared plus b squared is equal to 2ab plus bc plus ca minus c squared plus, actually minus ab, it's going to be. The terms contains the terms includes the a, I'm going to collect them together. This ab I'm going to send to other side to get a perfect square form here. A square plus b square minus, or let me write directly the perfect square form of it. A square minus 2ab plus b square is equal to bc plus, not plus, minus c square, and ca and minus ab, they have the same term, so it's going to be like plus ca minus ab. Okay, the c is the common term here, a is the common term here, then the a minus b parenthesis square, it's going to be equal to a minus b squared, it's going to be equal to b minus c times c plus c minus, or minus a parenthesis I will get. Then I will get the b minus c again. If I get plus a parenthesis, it will be c minus b. If I get minus a parenthesis, it will be b minus c. And I will get the common terms here. So when I get the common terms out again here, for this one I'm talking, here b minus c times c minus a, it's going to be. Here we are going to, we got this one for a minus b, but you can do, I choose here minus c squared, but if you choose different terms like a square or b square, you will get the same thing. And then it's going to be like this. Here, a minus b module square, it's going to be equal to module of b minus c times module of c minus a going to be. Here, a minus b, b minus c times c minus a, if it is, at the same time, a minus c or c minus a, c minus a square, it's going to be equal to c minus a square, what it will be. And then it's equal to a minus b times b minus c, it's going to be b minus c, or b minus c square, it's going to be what it will be, b minus c, if you get a minus b times c minus a, you're going to find. Okay, here, as I told you before, I send the c square to the other side, I got this one. If you send the b square to the other side, you will get this one. If you send the a square to the other side, you will get this one. And for what we are going to use this one, let's say here, if it is in this form, c minus a is equal to a minus b square over b minus c, it's going to be here. And in the second one, I mean in the third one here, in the third one, c minus a in module, it's going to be equal to b minus c square over b minus c, it's going to be c minus a is equal to b minus c square over a minus b. Yes. A minus b, it's going to be. So if they are equal to each other, a minus b square over b minus c, I made a mistake here, b minus c square I wrote here, modules, of course, they are equal to, here these two, they are equal to each other, so it's equal to b minus c square over a minus b module. If we crossly multiply, a minus b module cube is equal to b minus c module cube, it's going to be, which means a minus b is equal to b minus c. I made this one like this, and if you choose another term, if you choose a minus b, let's say a minus b is equal to c minus a square over b minus c, is it true? C minus a square over, yes. And then here you are going to get, by using this formula, you are going to get b minus c is equal to c minus a. Then we are going to get the third one, b minus c is equal to c minus a. Why this is important for us? Because if a is not equal to b, there are two cases here. A is equal to b. So a minus b is equal to 0. It will be like this. Or if a is not equal to b, it means that these are distances, they are equal to each other. And if you remember, in the complex number, if you studied the distance between z1 and z2, if this is two complex number like this, the modulo of z2 minus z1 gives you the distance between two complex number. I didn't explain this part before, but you already learned. I thought like that. So the distance, if it is equilateral triangle, it says in the question like that. If this is A, B, and C, and if all the sides are equal to each other, then if these are also complex point, the distance between A minus B and distance between B minus C and distance between A minus C must be equal to each other. And here we prove that one firstly. If the distances are not equal to 0, if the distances are equal to 0, it means that they are representing the same point. It says at the question at the beginning, if you prove that ABC equal to each other, ABC equal to each other, A, B, A is equal to B is equal to C, if modulo of AB is equal to 0, then all of them 0. If it is not equal to 0, second one, if A minus B is not equal to 0, it means that they are making equilateral triangle. Yeah. Now, yes, Drin, I didn't see your writings. Now I saw. Yes, you are right. Meaning that their distances are equal, which makes equilateral triangle, or if the distances are 0, because there are two possible cases here. That we don't know exactly what are the distances are equal or distances will be 0. If distances are 0, it means that AB is equal to C, A is equal to B is equal to C. Or if it is not, A, B, C are the vertices of the equilateral triangle. It must be. Now you have 3 minutes again. Try the question. I'm going to the question again. ABC are complex numbers. Yes. ABC are complex numbers, then where a plus b plus c is equal to 0 and a b plus bc plus ca is equal to 0. This is true only if a module, b module, and c module they're equal to each other. Like we made before, question here, going to do like this: if a plus b plus c is equal to 0 before this question, a plus b plus c, if it's equal to 0, a plus b it's going to be equal to minus c. So here we are going to do like this question. If they're equal to 0, I'm going to accept that these are equal to 0, then I'm going to prove that one here. I think because of the translation it will be like that maybe, but by the way, this is the question from the Sigma 354 and 354th question. Actually, it is. It's true if means if and only if. I think this expression is if and only if. I don't know that one exactly, but that's from the translation, and maybe the translation is also not good. Okay. A plus b is equal to minus c, then here I'm going to get a plus a, actually the second one I'm trying to write, sorry, ab plus bc plus ca is equal to 0. If I get c parentheses ab plus b plus a plus b times c is equal to 0, and ab plus ab is, if a plus b is equal to minus c, it means that this is minus c times c, which is equal to 0. And then I will get this one, a times b is equal to c squared. By the way, again, I'm repeating this part. This is not a question from the blue book, and I found from the Sigma. And a times b is equal to c squared. It's going to be. Then, if I apply this one, this terms, like if I do this one for b, I will find like, let me change the color. A plus c is equal to minus b. It will be. Then a times c, I'll find that b squared it is. Or if I do this one like a plus, not a, this is this time we don't have a, b plus c is equal to minus a, then I'll find that b times c is equal to, I'll find a squared. So this affects all the modules also, which means a times b module is going to be equal to a times b module will be equal to c module square. C module square. C times c, it's going to be c module times c module square, it's going to be. Then it's same also for a times c. A times c is equal to a times c is equal to module b module square, or the last one, b times c is equal to a module square. Here I'll leave one of them alone. I'm going to get this one like, I'm going to use this one, I'm going to continue with this one. The others, they are going to be an example for us. I'm going to leave a times b module, A module times B module is equal to C module square, which means A module is equal to C module square over B module. And here, sorry, what was the I'm very sorry about the microphone. Now, is it okay? Sorry, I came the end of the question. And okay, then I found A module is equal to C square over B. And here I'm going to get from the second one, yes, when I change something, it's having problem. Now I'm going to close this one again. I'm going to reopen. Okay. I think the problem will be solved. Then I'm using the second one now here. I mean, A module times C module is equal to B module square, which means A module is equal to B module square times over C module. So A module is equal to A module. These two, they are equal to each other. This implies that C module square over B module is equal to B module square over B module square over C module. And if we cross the multiply, we will get this term here. C module cube is equal to B module cube, which is equal to, I'm going to get a bit down, which is equal to C is equal to C module is equal to B module. I get A here, and I found that C module is equal to B module. If I choose another term, I will find another equality, and then I'll find that A module is equal to B module is equal to C module at the end. If I find C module is equal to B module by using the same methods, I can find aren't we supposed to from A plus B plus, aren't we supposed to start from A module is equal to B module is equal to C module? Yes, that's why I said at the beginning, I got this question from the translation. True if it says, the question says like this: A, B, C, and C are complex numbers. A plus B plus C is equal to 0, and AB plus BC plus CA is equal to 0 if and only if I said. If and only if I said. That's why if and only if, when we use if and only if the question is with if and only if, it has logic. Otherwise, here we don't have any terms to use. Or let me tell you this one. Also, I can do this one here. I can derive from, I'll start from this one. If A is equal to A conjugate is equal to, A module is equal to B module, let's say I'm talking about this one. A module is equal to B module, which means C module cube is equal to B module cube. Let's say B is equal to B module is equal to C module, which means C module cube is equal to B module cube, which means you can drive to this side. C module square over B module is equal to B module square over C module, which means A module is equal to B square over C square, which means I'm driving to the opposite side. Now, to this side, then I'm driving to this side from this equation. From this equation, I will get this one. From this equation, I will get this one. And by using these two, I will get these are. And if I get these are, I will find these are also. Then, if I know this one, I'll get this one, and I'll get these are. So it must be like that if and only if there is here if and only if there is if and only if to this side, how I solved, or I got this one and I drive to opposite side, I will get the same thing. This is not from Blue Book, this is from the Sigma. But again, I'm repeating here. If the question solution is not like this, let me give you this example. Let's say if I have C square at the end, if A module is equal to B module, C module square, C module cube must be equal to B module cube, isn't it? What I found here, I'm driving to negative side. I mean, if this is positive side, to the negative direction I'm going now. Then C module cube is equal to B module cube. This implies the upper part. Then this implies these parts. And this implies, this parts implies this one. Did we understand each other? Okay, then here I can do like this. A times B is equal to C square. I can get that one. And if I get A times B C squared, then I will drive like this. A times B minus C squared is equal to 0. Then I will get this one. For all of them, I will write and write again. Then I'll say like this. I will write all of them, and I will write here from this one to this one I'm talking about. One by one, if I write, I'll find this one. If A module is equal to B module, we will accept here A times B minus C times here C is equal to 0. Then yeah, here I'll get maybe this one, A plus B minus C is equal to A plus B. I will accept that. Let's say A plus B plus C is equal to 0. Then I will get this one. Otherwise you cannot get, by the way. Okay. Now, pardon, I have this question. Pardon, I didn't wait to write for this one. Okay, now I'm going to try to solve this question. Here, this is from another source, I don't know, from the sigmas, I think. Yes, prove that W is equal to Z minus 1 over Z plus 1 has only imaginary part if and only if Z module is equal to 1. As you see, they like this kind of things. Z module is equal to 1 or A module is equal to 1. They may ask this kind of question in the, if they ask in the regional or republic question, they may ask this one of them. And Z is not equal to plus minus 1 because if Z is equal to plus minus 1, then this will be undefined. That's why it cannot be plus and minus 1. Z is an element of complex number. Complex number means I'm going to use the general term for that one. Here, I'm going to use for the W is equal to A plus BI minus 1 over A plus BI plus 1. And it's asking that prove that it has only imaginary part if and only if. So first I'm going to accept that this has only imaginary part. This has only imaginary part, so I need to rationalize this one. And here the term is actually, it's equal to A plus B, actually, like this it is, A minus 1 plus BI over A plus 1 plus BI. I need to multiply this one by the conjugate of this expression to rationalize the denominator, and it will be like this: A plus 1 times minus, sorry, made a mistake, A plus 1 minus BI. If I multiply, this is the conjugate of this expression, I'll get the upper part here like this: A minus 1 plus BI times, here it's going to be A plus 1 minus BI all over. And if you remember, we said like this: A plus B times BI times A minus BI is equal to A square plus B square. So directly I'm going to write, when we multiply, A plus 1 parenthesis square plus B square. I'm going to say it like this. And here, if I multiply, this is going to be the multiplication result. Here there are 3 terms, so it's going to be a bit longer, like A times A is equal to A square, A times 1 is equal to A times minus BI is equal to minus ABI. Then minus, I'm going to continue with minus 1. Minus 1 times A is equal to minus A. Minus 1 times 1 is equal to minus 1. Minus 1 times minus BI, it's equal to plus BI. Then BI times A is equal to plus ABI. And BI times 1 is equal to plus BI. And BI times minus BI is equal to minus BI square in parentheses, or it's equal to plus B square, it's going to be. Then A and minus A, you simplify, minus, pardon, I didn't write the denominator. Denominator is equal to A plus 1 square plus B square, it's going to be. Then here we are going to get A and minus A, we simplified, minus ABI plus ABI, we simplified. Here what we get extra, this is minus 1. Do we have plus 1? No, we don't have plus 1. So it's equal to A square minus 1 plus minus, plus B square plus 2BI all over all over here. A plus 1 square plus b square. It's going to be here. If you divide by the denominator, because this is only the term that includes the I, that's why here it's going to be like this. A square minus b minus 1 plus b square is the real part over a plus 1 square plus b square plus 2bi over a plus 1 square plus b square. I can separate like this, or this can be like this. This is the real part of the number. This is the imaginary part of the number also. Or I can write like this: a square minus 1 plus b square over a square plus a square, not a square, a plus 1. Sorry, a plus 1 square, a plus 1 square plus b square plus 2b over a plus 1 square plus b square I. So this is the real part, and it must be equal to 0 if we didn't make any calculational mistake here. Yes. Then if this is equal to 0, it means that here it means that a square minus 1 plus b square, it must be equal to 0. Actually, it is not equal to. Let me not confuse you. Now I'm trying to do this part. This is the second part of the equation. It says that at the beginning, I'm reading again, it has only imaginary part. If it has only imaginary part, it means that the real part of this complex number, it's going to be equal to 0. So if real part of the complex number is equal to 0, which means a square minus 1 plus b square over a plus 1 square plus b square is equal to 0, means a square minus 1 plus b square is equal to 0. Implies that one, which means a square plus b square is equal to 0, which is a square plus b square. If you remember, I have chosen z is equal to, actually which one I have chosen? Yes, z is equal to a plus bi. I choose a plus bi. So if I choose a plus bi, it means that a square plus b square at the same time it's equal to z module square. So I found that it's equal to 1. Sorry, I sent this one. It means that a square plus b square is equal to z module square. So z module square is equal to 1, which means z module is equal to 1. And I'm going to read again the question. If and only if z is equal to z module is equal to 1. Here it is. And okay. How 0? Damian, you ask how 0? You mean this part, how it's 0? Yeah, I understood. Okay, I have this question also, but we finished the time. Okay, I understood now. And I have this question. I'm going to follow. I'm going to. I'm not going to continue. Later, if I solve this question, I will send you. You can, my web. I mean, YouTube address now. You can see the solution in YouTube address. I'll record and I will send this one to as a solution. I'm planning to solve all the questions again. I'm going to use one program for that one. I'm going to resolve the questions one by one, and I'm going to name the. Yes, I can send the questions as a PDF. I think I can write the chat part here if I print this one, export to PDF. Let me save in here. I'm going to send the link. I'm going to put the link here. Yes, I got the link now. It may. Yes, we finished now. I have one more question, and as I told you, I'm going to solve that question, and I'm going to put all solutions one by one as a question. One by one, I'm going to send them. You can follow from the same channel, and these are the solutions. Maybe I'll rewrite that one with better handwriting because my handwriting wasn't good. I try to explain. Yes, did we finish? Yes, we finished. Give us access. I need to enter my email. Yes, it started to come. I'm giving accesses. Give access, it says. For Monica Trayonova, I'm giving the access. Drin Kadriyu, I'm giving the access. For Mitre also I gave. So So for Darian, sorry for it's asking one by one. So I gave the access, and now you can, if it sends me directly, I'm giving the access for getting the PDF. So you may get this PDF. And as I told you before, I'm going to solve the last question, and I'm going to record the video. I'm going to put that one also in YouTube. You can find here. I'm going to solve these questions one more time. You're welcome, Christina. I'm going to solve these questions one by one. Each question, I'm going to make one video, and I'm going to record this one with one program, and I'm going to put them with different handwriting, I hope, to the to YouTube again. I'm going to upload. Probably after 1 day or 2 days, I will finish all of them, and you can see the solutions from YouTube again if you want. Okay. Thank you for your time. I got your time. Sorry for that one. I hope we will meet instead of this YouTube channel. We will see each other face to face. Hi. Thank you.